Hey everyone, my name is Anvita Bansal and we are back with another lecture based on bit manipulation. I'm just checking if we are live or not. I think we are. Okay, so I hope we are well connected. Yes, okay. So we will be discussing another problem from bit manipulation, and the problem for today is sparse number. So before we move into this problem, if you guys have attended previous lecture, that is yesterday's lecture, longest consecutive ones, then this is going to be easy to for you to crack how can we solve it. So I'll just show you the problem statement. So the question says you are given number n. Your task is to check whether it is sparse or not. What do you mean by a sparse number? A sparse number is any number whose binary representation does not have two or more consecutive ones. That means you want a number which does not have ones consecutively present in its binary representation. So if you find such a number, you return true, otherwise you return false. Okay, so let me just move to the board and show you. Okay, so let's take an example. Let me take the test case from here. Which one shall we take? Let's take a number on our own. Okay, so if we have 11, is that 11 and it's 3. I want to take a better example. Let me take from their view section. Let us take this example. Okay, so obviously for this test case the output should be true, and I'll take another test case which I will create on my own. So let me just write the test case here. So let's say you are given a number which is 72 whose binary representation is 0 1. Just ignore it. Okay, so moving ahead. So we have 0 1 0 0 1 and zeros. Okay, so this is our binary representation of n equal to 72. Now you can observe that in this binary representation you have 1 here, you have 1 here, but you do not have ones consecutively present. You do not have any set of ones which is consecutively occurring more than once. Okay, so if you had a number like this 0 1 1 0 1 1 1 0 or anything like this, okay, then this case would return you false because this is not a sparse number. But this is a sparse number. Why? Because it has ones which are not consecutively present in its binary representation, right? You are seeing one not occurring more than twice, 2 times or more than that consecutively. Okay, so that's how you define a sparse number. How can we solve it? So if I want to solve this problem, what can I do is, what thing that we can do here is that let's do a right shift on this n. So n, when right shifted by one position, so on doing right shift on n, what is the new number that you're going to get? So obviously when we do a right shift, we take off the least significant bit from here, move every bit by one position to the right, and what is the number we are going to get? So start seeing your number from this position and start writing it. 0 0, third 0, then we have 1, then we have 0, second 0, then we have 1, and then we have 0, and add up a 0 here, right? Fine. Now do a bitwise AND of these two numbers. So when I do a bitwise AND of these two numbers, what is the resultant I'm going to get? So you guys will see that I will get a 0 0 0 0 1 0 0 0 0 0. So did you observe one thing, that since we knew, I told you, okay, this is a sparse number, so expected result when I do such operation should be that if a number is sparse, then resultant of n and n right shifted by 1, if I see the resultant of this operation, it should always be equal to 0 if n is a sparse number. If n is sparse, then this operation will return me resultant as 0. Why? Because when I'm doing a right shift, since I do not have any set of consecutive ones, so no one will be overlapping or colliding with the previous one. You're getting this point. Try to visualize it in this way, that there will be, since there are no set of consecutive ones, so there is no single one which will be colliding with the previous one, right? This is the reason when I'm doing bitwise and I'm getting 0. Let's take an example of a non-sparse number. Let's see. Let's take an example. In this problem only, let me just modify it in this way and write it like this. So I'll take some consecutive ones. So let's say this, the number is 0, 1, 1, 0, 1, and let me add 1 here. Anything. Okay, I'm just writing anything here for you to understand. 0, 0, 1. So here you can see how many consecutive ones I have. This is single one, that's okay. These are the set of 2 consecutive ones. This is single one, no, we don't have to care about it, single one. So these consecutive ones make this number as not a sparse number. Okay, it's not a sparse number. Now doing this operation, how we are getting a result is, let's see. So I'm doing a right shift on this number. So what is it that I'm going to get? Let's see. When I do a right shift, I'll remove this bit and see your number, see your binary representation from this position, and start writing 0, 0, 1, 0, 1, 1, 0, 1, and then one more 0. Okay, now do a bitwise AND. When I do a bitwise AND, this 1, 0 is going to be, result is going to be 0. This is 0 again, this is 0, this is 0, this is 0, this is 1. Now do you realize why we got a 1? Because we right shifted each of the bit by 1 position. So even if I had these set of ones consecutively occurring, so when one of the ones got shifted, it somehow collided with the other one that was present right after it. You got this point? So this is the reason that I got this number non-zero, and rest will be 0, 0, 0. So now you see, whatever the resultant is, this resultant is equal to 1. It can be anything, but it will never be a 0. It will never be 0 if it is not sparse. Okay, so that's the conclusion of this operation that we are doing. Let's take one more example so that you can verify the operation, that what we are doing, how it is giving us the answer. So let's do one thing. Instead of 2 ones, let me take more ones. 0, 1, 1, one more 1. Okay, now when I do its right shift, what I'm going to get, let me take a number, just this much. Okay, so what I'm going to get when I do a right shift on this number, so when you right shift this number, this 1 will be removed and you start from here 0. You get 3 ones, 1, 1, 1, then you get 0 and 1, and you add a 0 here, right? So now you do a bitwise AND of these two numbers. You're going to get 0, 0. So here you're getting 1, here you're getting 1, this is 0, this is 0, 0. So we know whatever the resultant is, it is not a 0. That is the reason I can conclude that n is not a sparse number. So that's all. So how can we solve this problem? Let me just see if you guys are able to see my screen. I hope yes. Okay, so let's move and solve this problem. Where is it? Okay, I think that's right in front of you, but let's, okay. So what are we doing? We are checking. What are we checking? N. We are doing a bitwise AND of n with another number which is right shifted by 1. We are doing an operation that is shifting n by 1 position to the right, doing a right shift on n, doing its bitwise AND with n, and then we are checking if this resultant is greater than or equal to 1. Then I will return false. Otherwise, I'll return true. Okay, fine. N and n right shifted by 1. If this result is okay, let's check. That's all about this problem. I hope you understood this problem. That's all. Okay, so you guys can ask me if you have any doubts. Otherwise, we are done with it. Okay, then I think if you have no doubts, we'll wrap it up for today. Thank you, everyone. See you all in the next lecture. Bye bye.